The Dynamic Learning Maps Alternate Assessment System is a new assessment designed to more validly measure what students with significant cognitive disabilities know and can do. This presentation will provide an overview of the mathematical concept of unitizing for students with significant cognitive disabilities who will complete the alternate assessment. This training is one in a series of training videos that supports teachers with students with significant cognitive disabilities in their efforts to teach and assess. Sponsored by a grant from the U.S. Department of Education, Office of Special Education Programs, this training is part of the professional development efforts of the Dynamic Learning Maps Alternate Assessment Consortium. In previous math modules, we discussed development of counting and cardinality. Counting by ones is a task for students who are figuring out what a quantity such as 20 or 11 looks like, how to count efficiently, and how to represent that number. In this module, we will discuss the concept of unitizing, which builds on the student's understanding of numbers and is a component of place value. Unitizing is understanding that numbers can be arranged in groups, and that these groups can then in turn be counted as individual units. For example, 5 fingers can be grouped together to make a hand. The hands can be counted so that 2 hands are the equivalent of 10 fingers. Or, given a case of soda, one could think of it as 1 unit, 24 cans, 2 12-packs, or 4 6-packs. So unitizing is the strategic use of groups to deal with quantities and problem solving. Unitizing requires students to integrate their knowledge of number words, numerals, and quantities. For example, the number word 26 is represented by the numeral 26 and is counted as a group of 26 ones, or 2 tens and 6 ones. Or 3 blocks could be counted as one group, or 3 individual blocks. Pause for Activity 1. Although unitizing is the goal, students begin by identifying units made up of multiple objects or groups of objects. During instruction, teachers combine counting and identifying units. For example, when the student counts a set 1, 2, 3, 4, 5, the teacher asks how many are in the group. The student indicates 5 or counts the items again, and the teacher says, "Way to go, you've counted 5 bears." As the student becomes more proficient at counting, the teacher should begin to transfer the responsibility of naming the unit over to the student. But do you have to wait until the student can count before you start working on identifying the unit? No, this can begin even before a student is able to count. Teachers can begin to instruct as soon as the students recognize objects are the same or different. Creating sets of like objects and defining the attribute of the group is the beginning of what should become strategic choices to make groups in order to work with larger quantities. When a student creates a group or a set of yellow trucks and a group of cars, encourage the student to communicate how he or she grouped the objects. What properties did the student use? Some students may need to sort objects using tactile or auditory properties. If the student is unable to identify the properties, provide choices. For example, the teacher may say, "This group has cars and this group has trucks, but the trucks are also all yellow. Which group were you thinking about, yellow or trucks?" Then let the student use his or her mode of communication to identify the unit. If the student is unable to provide the property, model a response by saying something like, "I know you like yellow, and all these are yellow. You might have put all these together because they're yellow. Use the student's communication system to indicate 7 yellow. This type of instruction will help prepare students to think in units even before they begin to count with meaning. To develop a full understanding of a unit, students will also work on counting with one-to-one correspondence, stable order of counting, and cardinality. This way, they can think about 3 as 3 individual things or as a unit. More information on these concepts can be found in the modules Counting and Cardinality and Forms of Number. Clearly, there is a connection between identifying groups as units and categorizing. Categorizing occurs in all content areas and involves grouping objects or ideas according to criteria that describe common features or the relationships among all the members of that group. This enables students to see patterns and connections, and it develops students' ability to manage or organize information. When working on categorization, instruction should focus on concrete objects readily available in the classroom. Initially, the teacher will provide the property or feature by which objects are to be grouped, such as size, color, shape, or use. Students will later develop their own classification guidelines. Encourage students to communicate their reason for placing items in a particular category. Demonstrate this strategy with the whole class, then progress to small groups and individual categorizing activities. Students should move from concrete objects to categorizing pictures, labels, words, and information. So let's look at an example of how categorizing is important in forming units. When units are clearly defined, students find it easier to name the unit. In the first example, we see there are 3 buttons and 2 buttons, which are equal to 5 buttons. But what happens if the student has 3 buttons and 2 chips? Then we have 5 what? Students need to be able to identify a common category. In these cases, they are all circles. 3 buttons and 2 chips equals 5 circles. Forming units is a big idea or critical building block in mathematics. When teachers begin instruction, students will work with groups of the same objects to focus attention on single attributes, then shift the focus to finding common attributes when combining or adding groups. Pause for Activity 2. Being able to form units is a step towards understanding unitizing and a building block towards place value. Once students are able to do some counting, they will begin to progress through various levels of understanding. At first, a student does not separate number words or numerals by their place value. 26 refers to 26 cubes. The student simply counts by 1. Providing explicit instruction and plenty of opportunities to explore ways of separating items, the student begins to separate the tens and the ones into their number words. So 26 means a group of 20 and a group of 6, but the groups are still counted by ones. Then a student can count units in sequence, understanding that you count by tens and then count by ones. 26 cubes are separated into 2 equal groups of 10 and counted as 10, 20, and then the student counts on 21, 22, 23, 24, 25, 26. Finally, a student will count 26 as 2 groups of 10 and some ones. Tens and ones are very special units for place value, and our base 10 number system. At this level, the student integrates the use of number words, numerals, and quantities, and the student understands if you change the order of the numerals, it changes the number word and the quantity. Or if you change the quantity, it changes the number word and the numeral. In this module, we have covered the basic concepts of unitizing. In the next module, we will discuss place value and instructional practices that help students move through the levels of understanding. For more information about the Dynamic Learning Map's essential elements and the Dynamic Learning Map's alternate assessment system, please go to www.dynamiclearningmaps.org. Thank you for your participation.